one of the educators who joined our kickoff webinar said, "Oh, I really wish, I could analyze this in conjunction with iNaturalist." And we said, "You bet, let's build it." So that's what Ashley's been building for like the past month. So yeah, for any of you in the chat, you have voice, you have agency. If there are things we haven't built yet that you want us to build, tell us and we'll do it. Looks like we're
Sounds.
right at the hour, so I'll pass the mic to Cassie and we can go ahead and officially get started.
Hi, everybody. My name's Cassie Sofing, and I'm the campaign lead for the Globe Mission Mosquito Research Project. And I'm joined today by an awful lot of amazing people, and I can hardly wait for. I'm going to not talk very long, but I'm going to pass it over to Dr. Rusty Loeb.
Thanks, Cassie. Well, thank you for coming to what is this, Cassie? This is webinar number 80
Yes, it is.
campaign series. So we've been doing this now for a couple years. We're delighted to have you here today, and we're going to be talking about the Globe Observer Mosquito Habitat Mapper and also talk about the data and what you can do with the data. And we just have the greatest guests today. I wanted to just show you all the mosquito observations that are being made right now through 3 different platforms. Mosquito Alert, which is European based, Globe Mosquito Habitat Mapper, which is international, and iNaturalist, which is largely in the US and Europe. But we have come up with many different observations, and this is a platform that we use to share our data. And these data have been used in a wide variety of research publications. And you're also going to hear today about a really new and exciting project, which is led by Dr. Dee Yang and her team. Next one, please. So your data does make a difference. And I just wanted to let you to know that we have a new paper that we have just gone through peer review and we have just submitted. It's about the citizen science data that was collected in Africa and some of the work we're doing with invasive species there. So stay tuned, but your photos were used in the development of AI models that we are using now to identify different species of mosquitoes. And we also have a couple other publications too that are coming out. Next one. So for anybody here is new, if you're new, why don't you just let us know in the chat so we know who you are and where you're from. But this is the app. The app is called Globe Observer. On the platform, we have 4 projects that are always on this platform. That is clouds, the mosquito habitat mapper, land cover, and trees. And we always like to encourage everybody to use at least the mosquito habitat mapper and land cover together because, it is land cover data that you collect that helps us make the connection between the satellite data in the sky and the mosquitoes that we see in traps. And this is something that Dee's team is going to be talking about today. Next one. So in case you haven't done this before, it's a really easy platform and you're going to see a little bit more about it. They're also going to do a little review of this, but basically you open up the app, you find a place where you might find mosquitoes that might be in a tire or in a cut bamboo in a forest or maybe even in a drainage. You sample that mosquito, you look at it using a clip-on microscope, take a picture and upload the data. And this is the data that we are collecting to better understand everything that we need to know about where and when mosquitoes are found. And our whole goal is to reduce the global burden of vector-borne disease. Next one. And so it's really easy. We say it's easy as 1, 2, 3 because the first screen you get, you identify the location and the date of where you find the mosquitoes. In the second one, you describe where that watery habitat is found, where you find larvae. And the third part is to take photos. And then we take photos with the land cover tool, the mosquito habitat, and also then of the mosquito larva. Okay, next one. So if you want to know more about this, you can contact us. I'm going to give you our email in just a second. But just know that the Globe Observer is a NASA-funded app, and it can be used with anybody who's got a smartphone or a mobile device with a built-in camera. It's used in the field, which means you don't need to have wireless service when you use it, but you need to, once you get home and you do have wireless service, upload the data. And all the data that you collect is saved on the device and can be uploaded when you do have a connection, which is available. And all the data are open data, free for analysis, and is used by educational organizations, by scientists doing research like that article I was telling you about, and for vector control purposes. So it really is making an impact in the world. Okay, next one, please. So if you have any questions, these are our emails, and I'll also put these in the chat. So if you have any questions about the app or getting started or using this in your community, we're here to help you and to let you know. And now I'd like to introduce our guest speakers. So we're going to have a great talk today with four speakers that we have here today. Dee Yang is a professor and she works at the University of Florida. And she is now developing a new research program funded by NASA looking at modeling for climate change and dengue. And she is working ably by Dr. Nickerson, who is the communications lead for the project, and two scientists that are working in her lab, Olivia Zhang and Ashley Hayes. And I am so pleased today that you have come to share what you're doing with this project. It's a new project. We just started in January, right, Dee?
Yeah.
Right. We started in January and it's going crazy. So I don't know who's speaking first, but I will tell you that I have known Dee for quite a long time. We met actually at a scientific conference at a poster, and we've been good friends ever since. Dee, would you like to start us off?
Yeah. So thank you so much, Rusty, for the introduction. And if anyone can share the slides,
Yep,
pull the
I'm
slides.
on it. And I put them in the chat too for our people if we're moving kind of fast. I see some FCI students also popped on the line. Hi guys, I wanted to share this project with you. Olivia and I have been working under Dee all summer, so it's cool that you guys get to hear about our other life. But yes, okay, slides are up and they're also in the chat for anybody who gets lost at any point. So Dee, over to you.
Yeah, so thank you everyone for being here today. So today we are going to explore how we are connecting. We are going to give you an introduction about the Emerge program and also like to explore how we are connecting libraries, educators, community through the power of remote sensing technology. So we are very excited as a GeoDI lab. We are very excited to share how the NASA support project is empowering the citizens to contribute a lot of meaningful scientific research and also at the same time addressing the critical public health challenges that related with mosquito-borne disease. The next slide, please. So there are like 5 topics that we are gonna talk today. So first we are gonna introduce Emerge, and that will be on me. And then I will lead to Caroline and Ashley and Olivia. So, and then we are gonna provide a very hands-on tutorial for the Globe Observer app. And also by the end of today's session, you will have like a knowledge of the tools how to engage your communities in this important citizen science projects. Next slide, please. Yeah, so the citizen science is very important as a definition for all of us to understand and to have a better idea of. In a lot of time that the citizen science has emerged as a very powerful approach and that engage the public in a lot of meaningful ways. So and one of the most important biodiversity database that we remember that is the GBIF, is the Global Biodiversity Information Facility. So since 2010, the more than 50% of the data are contributed by the citizen scientists. So there are a lot of different platforms compared with the Global Observer like eBird, iNaturalist, and several others are very effective as well. So, and today we are gonna like tell you the story how those different activity for mosquito habitat is structured and all how we are collecting the data and can make sure the data quality works out. Next slide, please. And so, what is emerge? The emerge stand for like what we're writing here for now. And so environmental monitoring through education, research, geospatial engagement. So it's a 3-year NASA funded project running from 25 to 27. And our key objective, including the developing climate driven risk prediction models and creating AI-driven mosquito habitat analysis tools, as well as building a data framework that connects citizen science observation with the NASA satellite. So we are this is a teamwork with 4 different universities, the University of South Carolina Medical School, Emory University of Indiana. So next slide, please. So here we are having 4 different pillars about the community, educators, public health, and research. So in the community sphere, we are going to work with the public libraries and all those different type of communities that we can think of to kind of promote citizen science and the data protocol of the global observers, as well as for the educators, we are providing STEM curricula integrating different opportunities and professional development resources. As well as in the public health sector, we are really trying to contribute the disease risk monitoring and vector control coordination with some of the public health sectors. So at the end, we really want to let the researchers know that we are trying to develop algorithms. We are trying to make the citizen science data reusable. Next slide. And here is a flyer for our Emerge, and NASA is our partnerships. And here is our resources. And please sign up for our newsletter if you go into that. So if anyone can copy paste the link in the chat window, that'd be great.
And we also, one reason we wanted to do it this way is we tried to make the website as intuitive as possible, and everything we talk about tonight is on that website. So if you only have one link from tonight, geoemerge.com can be that link, because that's how you can get to the Globe app. That's how you can get to our data curriculum. It's how you can get to the hackathon registration, everything that we're talking about.
Oh, next slide, please.
Yep, and there's a little bit of a lag. Classic Zoom.
Caroline, can you talk about this slide?
Yeah, let's do it. And I also just want to reiterate again, like how grateful I am to work under Dee for this project. I think I've been working in the citizen science sphere for about 10 years now, and this is one of the most innovative programs I've seen in terms of, I just want to emphasize that to the audience, not only are you collecting data with the Globe Observer app about mosquito habitats and land cover, but you're also analyzing it. And that's the next step, right? That's how you can empower better decision making in your community. That's how you can really understand what public health risks there might be. So I think it's a really special project, and I'm grateful to work on it. And I mean, we're very Florida focused. I saw there were some Floridians in the chat, go Gators, including our FCI students. But I think the curriculum we've built is also applicable nationally and internationally. So even though the hackathon we have coming up is in South Florida, and we've had a lot of people around the state register, which is super cool. I think people are driving in for it at the Broward County Library in their makerspace. But it's going to be a whole day where we walk people through Emerge start to finish, where we have a contest and see who can come up with the best data visualizations that day. We're even going to do a little bit of art. We have all the different tracks detailed on the website. But, that's coming up on the 27th. So come if you're in Florida. I'm driving a carload of people down from Gainesville. So you're welcome to tag along with me if you really need a ride. But otherwise, if you can't make it, and we have virtual attendance options too. You can just email us. You can just use the curriculum. Those are the best ways to get involved with Emerge. You can come to our hackathon next weekend, and we'll walk you through everything start to finish. From wherever you are in the world. I know we got some Rochester, New York people in the audience. We got some people from other countries, which is awesome as well. The curriculum has easy to use tutorials. Ashley and Olivia are going to walk you through it, and then we'll be back again. I know Cassie made this a 2-part series, so we can troubleshoot with you, so you can use it with your community or your learners or whoever, or just yourself if you're just engaging with this yourself. But like I said, come to the hackathon if you're in Florida or you want to drive to Broward County, and then use the curriculum from wherever you are. All right, now let's talk, before we get into the curriculum itself and some demos and a coding assignment, and don't be scared by the words coding assignment. Olivia and Ashley are starting at 0 with you, so you can build up to where you need to be. So if you have no experience, you're in a good place. If you have lots of experience, you'll still learn something new, but it's very friendly. But we're going to talk a little bit about some of the why of this project before we get into how to actually analyze the data. So I will pass the mic back to Dee.
Yeah, so the story that way we are doing from Florida is facing a lot of growing threat for mosquito-borne diseases. So that is just an example for last year. We are having like a lot of dengue cases as well as some West Nile, but it's also like here are showing a lot of becoming more frequent and boost the mosquito population a lot of time after the hurricane storms. So, and this green chart is showing the significant increase in the recent years. The next slide. And here are some like global disease risk map that I find for different kind of mosquito-borne disease that we can see. Those are like mainly focused on the tropical, subtropical regions. And also like there are a lot of, there are several studies that on the top journals project the dengue risk, mosquito-borne disease risks by 2050, and the mosquito habitat by 2050. So the habitat will expand significantly northward and southward from the equator, and that putting hundreds of millions of people or at risk. So, and I want to bring out that a great scientific group in geography at UF is Sadie Ryan's group. So they are doing amazing research on that as well. So they are in the chat. They are in today's room. Thank you for coming. Yeah. So and here are some we are also going to use climate change models and trying to predict the risk as well. The next slide, please. Yeah, so those are like some basic understanding of the mosquito biology is very crucial for a like effective monitoring and control. So the mosquito life cycle consists 4 stages: eggs, larvae, and pupae, and adults. So those are like a circle, and the and different like cycle had different like length of days. So here we marked them very carefully, and so we are gonna see like, and those are some distributions of the major and the key species of the mosquitoes that in Florida. We can see those are the major water resources and the habitat they are living in, and like all those different type of disease transmission risk. Next slide. So yeah, and here I think I don't need much introduction. Rasi already introduced that before, and so we can go to the next slides.
Well, and one thing to emphasize too is like even though we focus on mosquito and land cover, I mean, if you're out there with like let's say you're facilitating a group and getting everybody to participate, and this app is so great for everybody from Girl Scouts to retirees, all ages. Just go ahead and do the other protocols too. Like you don't have to limit yourself to just mosquito and land cover. So just wanted to throw that out there. It's all great opportunities to collect data that helps NASA scientists like Dee.
Thank you, Caroline. Yeah, and those are steps that we are trying to collect the data by Globe Observer. So there are several tips that I want to mention here. So it is very highly valuable if you can make some measurement in like outside of urban area, like in rural area. So because that is gonna help us increase the data density a lot, and it's really like lifesavers for researchers, as well as if you have the time, if you have any capacity or capability, please do repeatable measurement as well. So, and that will be really great as well. So we are gonna have kind of like a time series analysis of multi-temporal. Next slides. Yeah, so here are some like where the magic happens. So the NASA Earth observation satellite provide a lot of really great data sources for like monitoring the Earth's surface from space. So there are a lot of sensors, but we are trying to kind of leverage different sensors to see what are the possibilities that if we can see the mosquito habitat or even microhabitat from the Earth. And so here I want to list some of the very great resources. For example, like the EcoStress, which is kind of the highest resolution for thermal, and that is like we haven't seen a lot of use for that one using for monitoring the mosquito habitat. Also, there are a lot of different new sensors that we are really trying to take advantage of from this project. So next slide. Yeah, so that really comes to the research question, or the main goal is how we are actually, there will be like a different scale for the mosquito habitat as well as for NASA satellites. So how we can kind of like zoom in and out smoothly with both. And so we are gonna develop a globe observer to be trying to be consensus with the NASA satellite monitoring, Earth observation systems. Next slide, please, to fill the gap. Yeah, so here we are seeing that there's kind of like a data scale gap that from 1 meter, 10 meter, 100 meter, even to 100 kilometers. So, and that is where our like most of the yeah, the Landsat is 30 meter. It should be a little bit to the left, but we are seeing actually where our like mosquito breeding sites and the globe observations are actually taking out like the meter like from 1 meter to 10 meter scales. So that which bring the global observations or monitorings kind of like important drivers for bridging the data gap that we can see in this picture very clear. So next slides, please. Yeah, those are like our research. On the right side is we are trying to, it's just a test study that we are using the CMAP6 trying to predict the future temperatures. So that is 2050 that projected. So the temperature is the one that we are gonna facing changing a lot for the future decades. And as well as we are having the like the urban heat island effect is kind of like the perfect storm for a lot of the mosquito habitats. And even by just 2 to 5 degrees Celsius warmer than surrounding rural, we are seeing a lot of mosquito development conditions. Next slide, please. Yeah, so here are some of the great numbers from the citizens' contribution. So if anyone can see that is yeah, so those are like kind of like based on the globe observations, what are the distributions of the major mosquito breeding sites and the total number of countries and the contributions from the globe mosquito habitat observer. So we can see that here are the data trends and it's tens of thousands of data and with the pictures and imagery. And those are very valuable. Next slide. Yeah, those are the example of the water resources. Caroline, can you take over from here?
I got it. Yeah. And I think this is helpful too, because so you all heard, we also, I saw Gustavo in the chat mentioned, oh, wow, I really love these slides. It's like, we actually had a lot more, but we had to cut quite a few. So we would have time, because we could talk about the research that the GeoDI lab is doing all day, but we wanted to make sure we had enough time to get through the coding piece and make sure you all have your assignment for next webinar. But if you like, if you're like me, I'm a little simple. Sometimes it's like, how do I conceptualize this in my head? One way you could look at it is just you use the app, you document habitats like the ones you see before you, like standing water and things like that. Then you follow the simple instructions Olivia and Ashley have queued up for you to analyze the data. And then when you want to get a little deeper, you can use slides like the ones that Dee prepared and the GeoDI lab has done to like really hammer the analysis home and all the exciting and interesting ways they're understanding our world and using citizen science data to do that. But when you're out in the field, these are what the habitats themselves actually look like. I think we're almost to the coding assignment. Dee, if you want to take us home with the climate models piece, then we'll get to coding.
Okay. Yes, we are also trying to, for right now, a lot of climate models are very core scale. And then also we are having those a lot of the ground truth data. So we are in this project, we are gonna develop also like the downscaling methodology to bring up like to downscale a lot of the climate models on smaller regions. So yeah.
Awesome. Yes. So that's why it's so important to have people like you and the people who are in the chat in the room with us tonight, the educators, the students, the people of all ages out here taking observations from the ground, because that helps us scale things down so we can understand, predict disease risk. So, okay, how can you get involved? As we mentioned, use the Globe Observer app and or lead others to use it. And also, Rusty, this picture is you, isn't it? Yes. I think I was like, "I think this might be a picture of Rusty." I found it on the SciStarter website.
Yeah, it's not me, but I took the picture in Brazil actually of two teachers.
There we go.
Yeah.
This picture came from Rusty's device. Yeah, this is what it would look like if y'all were out in the field with your teacher friends or any friends you have making observations. But yeah, so step one, just use the app. That's a great way to get started. But then step two, when you're ready to take it to the next level and get into some of what Dee just talked about, creating interesting models and like starting to predict things and like the next steps on top of the data, you can start to analyze local and or global data to understand public. So Olivia and Ashley have made it easy for you. Let's get into their coding tutorial. That's what we're going to use the rest of our time together tonight to do. And as a reminder, all the resources, if you only take one link, are on geoemerge.com. And I also recommend, and we link to it on the website, but going to Globe Observer's website directly because there are all sorts of multilingual resources and great things. But if you lose track of anything, you can go geoemerge.com and find your way to the curriculum and some of what we talked about tonight. But that being said, I'm going to pass the mic to my colleagues. And thank you again, Dee, for teaching us. And I always learn so much from you. But I'm going to pass the mic to Ashley and Olivia to walk us through the coding activity. So it's the rest of the time belongs to you both.
Awesome. Thank you so much. So I just put the link to the coding activity in the chat and I will also share my screen. So are you able to see my screen?
Yep, looks great.
All right, perfect. So when you open the link to the coding activity, it opens up this link. And this is a Google Colab notebook, and it's essentially a way to run code on your browser, so you don't need to download anything to your computer. And in this activity, we show how to visualize and analyze the globe, mosquito, and land cover data at a global scale as well as state and county levels. So, just a quick introduction to how you can kind of go through this code is when you run, it wouldn't be saved because everything is kind of on your browser. But if you do want to save a copy of this for future reference, you can go to File in the top left and then click Save a Copy in Drive. And then this will just save a copy of it in your Google Drive. So you can kind of think of this as a Google Doc if you've used that before. It'll just be saved as a file in your Google Drive.
And really quickly, Olivia, I think one thing because I know there are some coding novices on the line, don't be scared of this. Like, the reason Olivia and Ashley set it up this way is so, like Olivia said, you don't have to download anything. You can just write code completely in your browser, almost like you're writing in a Google Doc. And Olivia, maybe you can define just like what coding even is, right? It's just a way of giving instructions so you can do different things with the data and understand it better, right? Or how would you define what coding is and what we're doing right here?
Exactly. Yeah, it's giving instructions to a computer to do calculations for you, make images, in our case, making maps. And I really like coding because it can kind of do things like making calculations a lot faster than if we were doing it by hand. And in this case, for the globe data, we have thousands and thousands of points all around the world. And so coding is a really useful way to analyze all of that data and to kind of get information, like get insights from it that we wouldn't otherwise be able to do if we were just looking at like the raw data. And so we like this, and we also like using this kind of coding environment for teaching and education more generally because it's meant to be a more beginner friendly platform in that everything just runs on your browser. You really only need a Google account in order to use it, and then you're able to run all of this code for free. And so that's why we kind of introduce coding through the Emerge project using this kind of platform in Google Colab. And then more specifically, we introduced Python as a programming language because it's a very popular and commonly used language for different tasks like analyzing data, automating things, making software, also training AI models, and a lot more. So we kind of have kind of a bit more information here. And then to run the code, you can click the arrow in these blocks of code here, and then it will run all of the code at once. And then you'll get this message that the notebook was not authored by Google, and then you can click run anyway. So now we have this, and then you can kind of go through the rest of the cells here. And so this is just kind of like showing like printing today's date. And then what we like about Google Colab is that you can have the code and then you see the output of it like immediately after. And so this is very useful for seeing like what the data looks like and everything. And then I will pass it to Ashley to talk a bit more about this.
Hi, I'm Ashley. So Olivia painstakingly wrote comments for nearly every single line of code, and so there are explanations for what every single thing is doing. So when you go down, you'll see the first kind of chart of our raw data. So the mosquito list, the country, the elevation, where the photos are, that is all available right there for you, and it has all of our data here. And so when you go down, you can add a little more, mosquito.info. It'll create a list. That list is what Colab is interpreting. And when you scroll down a little bit more, you find that there are 43,000 rows in the data set. And that is 43,012 citizen science contributions from 2018 to 2024 from 95 different countries. And so just clicking these buttons allows you to handle so much data at once, so many things, and just with a little click. And so we find right below there are habitats, water types, everything that the citizen science users have input into the system is available to you. And you scroll down where they are, whether or not they're jars or animal troughs or whatever, it is all ready for you. So you scroll down a little bit more and you can pick something as simple as your color palette. If you want to make it pretty, whatever makes you happy, it is your data set. We want you to experience it in your own way and really have fun with it. It can look really daunting, but as soon as you start clicking those buttons, you start seeing the visuals and things become much clearer. And so we have this cute pie chart of like all the differences and what like sources there are for our data. And I'm going to pass it back to Olivia.
Okay, so the next part of this is going more into mapping. So for this part, we're looking at for each country where the globe mosquito data was submitted, what is the average number of larvae, of like mosquito larvae that were reported. And then we're kind of loading in country boundaries, which is what allows us to like visually see it on a map. And then this code, we can kind of see like for each country, the color corresponds to the average larvae count, which is from the calculated from the globe dataset. And then something else that you can do with Python is making interactive visualizations. So for this next part, we're looking at kind of creating an interactive map of the globe observations from all around the world. And if you hover over a point, you can kind of see like what number of observations there were. So for example, like for the US, there were over 7,000. For Canada, there were 30. For Thailand, for India, sorry, there were 431. For Thailand, there were 18,000. And so this is just kind of like a cool way to see like all around the world how many like global observations were submitted. And then this next part, we're looking at land cover. So we kind of focus on both the mosquito habitat mapper and the land cover for the emerge project because we feel like land cover is a really good supplement to understanding mosquito habitats because there are specific types of land covers that maybe make it more prone to the mosquito risk. And so we look at this, and there's over 50,000 land cover observations that were submitted. And so this next part of the code is kind of visualizing the land cover data. So it's similar in a similar way to the mosquito map. And then this, we also kind of included like a challenge, which is kind of like a coding exercise to make an interactive map for land cover in a similar way that we did above with the mosquito habitat mapper. data, and so it would be kind of making a similar interactive visualization here. I'll skip over it for now for the sake of time, but in the code, it kind of includes this template that you can reference, and then you can also run this to kind of see the like one way to answer this question and one example of what this interactive map can look like. And again, it's just showing the observations along with this additional data about the most common land cover type. Okay, and now we're going down into the more customizable section. So for this part, Ashley, do you want to go over it?
Yeah, I can cover it. So here is where you can start getting really personal with it. We have something simple, your state name. You can put in Florida, you can put in Montana, you can put in whatever you want, and it will start to load the counties within that state for you. So you'll get down and we put Florida just for easy use for us, but that'll create an empty map for you and add all of the data for you. And so you scroll down, we're panning here to the state of Florida, and then you can input your county name. And this has data based on citizen science observations. So not every single county within this map is going to have data, and it is just because that doesn't mean we have anything for it. We'll keep this updated, but it is from 2018 to 2024. And so if you can't find your state or a county within it, is just that we don't have that data. You can change it. You can use a big city. You can use something in Florida because we have a ton of observations. It's just to get you accustomed and see the visualization. But you scroll down, you'll put in your county. I think we put Brevard, and it'll load the boundaries for you in order to see how many points there were and what percentage of them were made by the community.
Yes, and also for this one in the Globe Observer app, at the very end, after submitting their data, the citizen scientists have an option to kind of mitigate that mosquito habitat. So if it's like a tub of water, the app will kind of recommend you to like flip it over or remove the water, so that kind of eliminates the risk of mosquitoes taking over that site and having that like breeding mosquitoes into the future. And so this kind of shows like not just the number of observations that were recorded, but also what percent of them did the citizen scientists like remove the mosquito habitat.
Awesome. And then when you scroll down, there's more visualizations and how many were done per year in your county. We have a pretty big gap here, but our goal with this is to get more people using the app so that we don't have this giant bar and this teeny one. We want you guys to add and create this global database. Scrolling down, there's another lovely pie chart about water source types, this time specifically within your county. And as you change your state, your county, this will all be updated by itself. There's nothing more you need to do. Olivia did a great job writing it. And so it's really just setting it up and making your own observations based on the data. I think the hardest part of this, honestly, is just simply getting down into the Google Earth engine. Google Earth engine is another really powerful tool, pretty similar to Python, but what we did with this Google Colab was combining them. We have a tutorial link from our curriculum because Google Earth is really involved in everything we do. That is what loads the satellite data for a lot of the processing. And so in our textbook, we have a link right within the lesson on how to create your own account.
So this leads us to our kind of online book that has a bit more information. And specifically, we have this chapter which shows you how to create a Google Earth Engine project and set it up. For educational purposes, Google Earth Engine is completely free. And so kind of through this curriculum, we can have access to it for free and as well as in classrooms. So we do want to kind of go over this really quickly because we know it can be kind of confusing to make a Google Cloud project. And so kind of the first step here, and you don't have to create this now, you can do so later, but just so for reference, you can go to this link here and then click register under register your cloud project. And then it leads me to this page because I already have a cloud project created. But if you don't have one created, it will look like this. And then you can click create project. And then for the name, you can put anything like you could put emerge lessons, or for me, I just have emerge or something else, and then click create. And then after that, it will lead you to this page where you can click get started under see if you're eligible for non-commercial use. This is because Google Earth Engine is only free for kind of non-commercial use, including education. And so this just kind of confirms that you are using it for educational purposes and can get free access. So after that, you have different options for it to choose. So for the selecting organization type, you would choose Earth Engine Trainer or Trainee. And then as a participant, for the start date, you can put today's date. And then for the end date, you can kind of put when you expect you would be finished with kind of learning more about Google Earth Engine. You could put like next week by the end of our second webinar, or you could also put like longer if you want to explore a bit more with Google Earth Engine. And we'll talk a bit about what you can use Google Earth Engine for in a second. So after that, it will lead you to this page and then you can click register. And then at the end, you can click enable for enable required APIs. This is what allows you to use Google Earth Engine with Python and read in the data directly using Python. And then that's done and you can close out the page and then go back to the notebook. And again, all of this information is available on our digital curriculum, which is linked in this notebook, so you can always go back to it. But essentially, after that, you can go and load in notebook. So I'll just put this, and then this is just the name of your project. It's not like anything that's like needs to be secretive. Like it's kind of just like a name that's used, not like a password or anything. So you can put that there, and then this will kind of load in your Google Earth Engine, and it if you're doing this for the first time, it will ask you to kind of sign in to your Google account and then kind of give it some like permission so that it's able to run in Google Colab. So now after that, you can kind of use Google Earth Engine to load in lots of different environmental data. And so we kind of look at this one to begin with. So this is the NASA MODIS land surface temperature data. And so this provides data like at a global scale for like multiple different years, like over multiple years that you can use in to load in like temperature data. And then I also want to highlight all of the other data types that are available with Google Earth Engine. There's climate and weather data. There's also satellite imagery, and we have this for multiple years as well that you can read in specific times. There's geophysical data, and all of this is available for free with that educational license that you have access to. And also, what's great about Google Earth Engine is that all of it is running in the cloud. And so you don't need to download anything to your computer, although you do have the option to do so if you would like a downloaded version of the data. But because it's all stored in the cloud, that makes it really fast to load in very complex and large environmental data sets. And so that's why this is a very useful tool that we use. So we kind of include Google Earth Engine in our educational resources, as well as we're using it for our research itself to kind of forecast mosquito disease risk and other things as well. So it's a very powerful tool. So for this part of it, we're kind of initializing the map. We're defining some dates that you can use. So that for this one, you can customize it. It's set to be like June, like the start of June to the end of June. But you can also change it if you want to look at like what it looks like in winter time or another season. You can look at that if you're interested. You could also do it kind of for the whole year, so from January to December. And then this is just some like clean like converting temperatures from different scales. And then for this one, we are mapping out the temperature data for Broward County. And then you can kind of zoom out and zoom in to see where this is. So in South Florida, you can see it looks very hot, which I can confirm living in Broward. And then this is just kind of that scale. So it's like it goes from 50 degrees to 100 degrees Fahrenheit. And then this is also adjustable as well if you would like to change it and look maybe more on like the colder end versus the warmer end. And then for this one, we are looking at the average temperature. So we can see, okay, the average temperature for Broward County from June of this year was 88 degrees Fahrenheit. And then, yeah, this is just a super useful way to not only visualize data, but also kind of get summary statistics and other information. Now for this next part, because we are very interested in land cover and land use, kind of like understanding the what the land is looking like, we have this code which allows you to kind of compare land use in your chosen county from 2024 to from 1985 to 2024, so you can kind of see the change as well. And then here it kind of shows what each color represents. So for like pink, it's developed; for green, it's forest and other things as well. And then I have my like notebook in dark mode, so that's why it has a dark background. This looks better on a white background. And then for this part, we can also kind of print out like numbers to see like what percent of the county belongs to these different land classifications. And then I also see Dr. Ryan wrote in the chat, is there any way to not allow the notebook to have permissions to see, create, and delete all of your Drive files? Oh, yes. So when giving access to Google Earth Engine, it does request that. And I have tried not giving it permissions to do that, but then it doesn't allow Google Earth Engine to be run. But the main reason why it asks for those permissions is because with like Google Colab and Google Earth Engine in general, you're able to read in data from Google Drive, but that's only if you choose to. So there's specific code that you have to write in order to read in and load and write or even delete your Google Drive files. And so none of our code in this notebook does any of that. None of our code will kind of change any of your Google Drive files, but it does seem like they ask for those permissions to do that in order to run. I think that that's just a Google Colab thing. They just ask for kind of certain permissions before it lets you run the code.
The thing I do is I have a separate account that I run my collab in. There's nothing in that except for those files. And it also just keeps it clean, because one thing that a collab will do is add like a folder. You have like a specific collab where all of your notebooks go. And so if you want to keep that kind of separate and not give it access, you can add like child account to your regular email and just run it separately. But it doesn't require a lot, and Google is really easy with it. Like, you can set up the account on whichever, as long as you're eligible for non-commercial use.
And I know we're almost to the end. We should get to the challenge we have for you all, the opportunity that you all can work on before we meet again. When you registered for this, you had the option to sign up for a second session. That second session is where we'll have even more conversation, discussion, and like debugging and all the things. But Olivia, Ashley, we should probably pivot to the opportunity, or the proposed opportunity we want everyone to work on.
Yes. So for that one, we have actually, we briefly mentioned it, but it's this section where it's making an interactive map for the land cover. And so this is something that you can kind of like work on and kind of experiment more with, and then we'll be talking more about it in the next webinar. And then something else that we also encourage you to do is to test out different regions, so like different states and counties, and then explore the data available there. And then the final section that we have after we're done with the land cover analysis is kind of like tying it all together. And so for this one, you can see kind of like looking at the data for your chosen county. We can choose one of these points. So like, for example, I'll just choose this one. And then this kind of code, it's like pre-written and we have more information in our digital textbook. But this one will kind of get the different environmental data for that point and then like print it out here as well. And so kind of another challenge, if you're interested in kind of learning more on the Google Earth Engine side and kind of connecting it with the globe observations, is to add additional information here. And so we kind of started by doing a quick calculation of the NDVI, which is explained a bit more here. It's a vegetation index that's calculated from satellite imagery that tells us like how like high levels of vegetation there are at that area. So our kind of final challenge before we close out for this webinar is to find out what additional data you can add to go along with this point. And then you can find out more by going to the Earth Engine data catalog here and then kind of finding like different data sets here. And then you can kind of load in the data with this link here in a similar way as our other data sets, feed those in. And so that is our kind of additional like mini challenge for you all is to see what other data sets you can find that might be interesting to consider along with these mosquito observation. All right, so that's all I have for the coding activity and our challenge for you all. And I think I will stop sharing my screen so we can kind of close out. But yeah, I'd love to get everyone's thoughts about this. And again, we're always open if you have any advice for improving this, as well as for improving our kind of more broad like curriculum itself, where we kind of show bits and pieces of what we covered today in more detail. We're very open to your feedback on how to improve it as well. But with that, I will hand it over to Caroline to close us off. Thank you.
Yay! Thank you, Olivia. So, Olivia, if you want to drop in the chat just some parting links for everybody. So, I would say the link to the curriculum, because that will guide you all as you go on this adventure, and then the link to the assignment. And then we'll see you all back here. I know Cassie's probably going to send out again the registration in case you didn't register for the next session. We'll see you all back here again, and we'll go through what you all worked on. And as you're going through the curriculum, like I said, if you see anything where you're like, oh, I really wish we had XYZ, tell us. We'll build it. Ashley's been building the iNaturalist data integration because someone asked for it. So don't be shy. We want to brainstorm with you and build something great. We started off in our backyard of Florida, but we're ready to expand it to the country and around the world. So let's keep building great stuff. I think we have time maybe in our last minute for one question. If there's like a burning question people have, I'm seeing a lot of thank yous. The curriculum is the main tutorial. Bye, everybody.